Welcome once again. Today, again, we're going to go over how relays work, but this one is associated with the compressor, the air conditioning system. As was before explained with starter motors and fuel pump, same idea. Now, this is the input. This is the most important. This is called the control unit, and this is called the load side of it. The load is connected to this. Now you're going to ask, what's the load? The load is the compressor clutch. Now, over here, as we spoke about before in previous videos, we were talking about the computer has control over starter motor relays, fuel pump relays. This by no means is no different. Computer has control over the clutch relay also, operating the clutch. Now, as we spoke about before, this relay over here has a fuse, as you can see, hot and run and start. First of all this relay, these fuses can be found actually in the fuse block under the hood. When you ever see a dotted line, that means whatever in the dotted line is associated with whatever is over here. Now, we have current flowing over here through a 10 amp fuse, not too high rated. Remember the first thing I said to you yesterday, excuse me, was look for main components. When you're dealing with a schematic, the first thing that should come to your mind is forget about the wiring, forget about the fuses, or the connections or the connectors. I just look for main components. What's the main components in this schematic that sticks out to you, that catches your attention? Number one, the compressor clutch. That gets my attention right away because that's the load. What do I mean by the load? That's the thing the component that's gonna do the work. If you have a fuel pump, that's gonna be the load because that's the component that's gonna be doing the work. So this is the compressor. This is the clutch that it's engaged to the compressor. Now, another thing catches my mind is the computer. Main component. Other thing is the relay. Those three things catch my attention right away when I see this. Now I start to apply everything, how they are connected and how they work together. Number one, I know how a relay works. We went over it. I know how a clutch works. It's a coil and with a magnetic field, and now this has to have current flowing through it. Okay, fine. The difficult part over here is the PCM, which is the main computer. You remember I told you the power control module controls engine, airflow ratio, engine. Well, where does the compressor go to? What controls the clutch? The pulleys, the engine. So since it's associated with engine, the PCM is involved. Okay, that's great. Now, whenever we see something in a dotted line, this is the rule. Whenever we see something in a dotted line, that means whatever is inside this dotted line is associated with whatever is over here identified. So all this is identified with the PCM. That means, where can I find these resistors? Are they outside? No, they are internal. They are inside of this computer. This resistor and this resistor. Low pressure switch is to make sure that the pressure is not too low. If it's 5 psi, that's very low. So what's the computer going to do? The computer is going to open this switch. This is a switch. Now, you have 12 volts inside the computer. We give 12 volts to the computer at startup, always. But he needs a signal before he can activate the relay for the compressor. He has to make sure the pressure is the correct pressure. He has to make sure it's not too high. He has to make sure it's not too low. Both of those combination will activate the relay. And he'll say, okay, I'm good to go. I will activate your relay. Okay? But when does that happen? When you put the switch in maximum AC or over here, as you see over here, by level AC, for these regular AC, all these over here is a request for him. He acknowledges the request, but on one condition. See this? All this is a request. As we went over before, this goes to an AC high pressure switch. You requested to put on the air conditioner. It's hot, it's Florida, it is hot. You requested to put on the air conditioner, and you told the computer, I need some cold air right away, right? The computer says, not so fast. I can't do that because you know why? I have to make sure the high pressure switch is correct and is closing the circuit. So therefore, the compressor has low pressure on one side, vapor, and it has high pressure on the other side. The high pressure side is the hot side. When you feel it, it's hot. And where does it go to? The condenser. So with that in mind, what do I mean by high pressure? That means there's a certain amount. Let's say 450 psi or 500 psi is too high. That's going to damage the components. Computer, knowing that and taking that into consideration, says, okay, I want to make sure that the switch is in the correct position for me to operate before I operate the compressor, because otherwise I'll damage the compressor. When is that active? When he sees this in this position. When the high pressure is too high, let's say it's 500 psi or whatever, right? This is going to open. When this high pressure switch opens, guess what? You don't have a circuit over here, complete circuit. It cuts it off. It's a safety valve. So he gets the request and he says, okay, high pressure is good, fine. Then he goes over here, I got the request. What about the low pressure? Now he gets a signal from the low pressure that this is grounded. When this is grounded, that means the low pressure switch is closed. That means the low pressure is correct. In other words, if it would be 20 psi, it's okay. We'll close this switch. If it's 5 psi, a computer says, oh no, this is open. If this is open, I don't get 0 volts because this goes to ground. If he sees 0 volts over here, he knows AC low pressure switch is closed, low pressure is okay, I'm good to go, and I'll acknowledge your request. How will he acknowledge that? By giving this relay a ground. Okay? Now, so he looks at this and he says, okay, good, I'm 0 volts over here to ground, I'm good. I'm good. I have a request from the driver. High pressure switch is good. A low pressure switch is good. I'm good to go. I'll give you a ground. We studied yesterday about relays. One side is a 12 volt line. Other side is a ground. The computer could give the 12 volts. The computer could give a ground. In this situation, he gives you the ground. You see this toggle? You see this ground? It's in the PCM. Internally. We have no control over it. He has control as long as he knows the pressure is correct. And he will not damage the compressor. Go over here. We go over here. Current flows from here to here. Inside this fuse, coming out the fuse, into this relay, this connector, and this is terminal 86 I put, coming out 85. We'll go over it, connector C2, into this dark green wire with a white stripe, going into, this will be pin 43 of this computer module, and this is a ground. So now this is grounded. What does that mean? That means current can flow, and it's a complete path to ground, which we need. He gets a magnetic field. When he does that, he closes the switch. He toggles this switch. When he toggles this switch, now this switch provides a complete path from here to the clutch, to activate the clutch, to engage the clutch. So in conclusion, the computer controls it. If you have a problem with the clutch not engaging, the first thing you do is you look if the clutch is engaged. If not, remember, it's just not a relay, and it's not always the compressor. Computer is involved. Could be the low pressure switch. The high pressure switch is not giving the computer what he wants. Let's go over it now. 86, 85. Over here is 30 and 87. Let's look at the... I tried to get you one that you can see easier. This is the relay. 5 pins over here. 5 pins. Now, let's go over here. These two is the coil part of it, with the resistor across it. This one is the switch part of it, the contacts to the armature. Which is which over here? Let's see if you can identify them. This one, 86, this one, 85. This one, these two are associated with these two, the coil part of it. Which side is the switch part of it? We said 30 is the one that has the 12 volts all the time, and the 87. As you can see over here, 30 is the one that's always connected to the 12 volts. This is the one that toggles. You see this? You see this open one and this closed one? That means this is the one that toggles. That's the one you want. So if I'm going from 87A to 87, so 30 to 87, 30 to 87. The other side of it is a switch when it's closed. 87 is when it's closed. So these two are these two. These two are these two. Okay? Now, problem, compressor doesn't turn. The clutch is not engaged. How do you go troubleshooting it? I think I made a video, a hands-on, how to measure the connector to the clutch. Please go to that video. It's on Joe Electronic Schematics for Auto, and it's on the other channel that I'm trying to promote now. Automotive Electronic Schematics for Joseph. Please, Automotive Electronic Schematics for Joseph. Please go to that one because I'm trying to get views for that one now. Now, you're going to see, where first do we go? Now that you understand this, okay? And then if you look on the bottom, you'll see they are numbered over here. I'm not going to go over it because I went over it on the video. The main point over here is to understand the relays over here. How to attack the problem. What's the first place that you go if you don't see the clutch engaged? Remember, there's a diode across it. Fine. That's to suppress the spikes when it opens and closes. Now, over here, where's the load? We said this is the load. What did I say in the other videos? Always go to the point that's closest to the load. Which point is the closest? Is this the closest? No. This the closest? No. This is the closest. There's a connector here. Right? There's a splice over here. So, I'm going to take this connector out, which is B, and the other one is labeled A. I'm going to take the connector out. One goes to ground, and the other one... The one that goes to ground is black and a white stripe, and the other one is a dark green, which has the 12 volts to it. Okay? Now, you could do two ways. You could do it two ways. I could take the connector out, and all that's going to show me is that I have 12 volts. That's not bad because you know why? If I have 12 volts over here, that means all of this relay is working. That means he is active. He has current flowing through it. Why does he have current flowing through it? Because the computer gave him a ground. When the computer gave him a ground, he did us a favor. He engaged him. He activated him. The fact that I have 12 volts over here when I pull out this connector tells me this is in this position. It toggled. Why did he toggle? Because he got an electromagnetic field. Why did he get a magnetic field? Because he got 12 volts and the computer gave him a ground. He had a complete path. You could do that way, pull out the connector like you saw. Go to that video and you'll see what I'm talking about. How to measure the compressor clutch. What I did was, I didn't take the connector out. That's all it's going to tell me, it's 12 volts. I left the connector in. I put a wire in the terminal measuring with it. What happens if this is shorted? What happens if this is if this pulls down the voltage? Instead of 12 volts, what happens if this is 9 volts? What happens? That's why I want to measure it in the circuit. If this is 9 volts, guess how much this will be? This will also be 9 volts. And the whole supply might be pulled down to 9 volts now. So, in that case, if I measure it in circuit and I measure 9 volts, then I pull out the connector and I say, does it normalize? What do I mean by normalize? Does it go back to 12 volts? If I have 9 volts with this connected, I disconnect it. I detach it, the connector, and this is 12 volts. That means this is pulling it down. Something is wrong here. Maybe the diode is not good. Maybe the clutch itself is not good, the coil. Okay? But in case you don't go to the connector, where would I go? As you always know, what I do is I always go to this one. If I measure 12 volts over here at the relay, that tells me this is working. This is working. Most important part is this one over here gave us a ground. That's good. If it gave us, why did it give us a ground? Because the low pressure switch was good and the high pressure switch is good. And he received a request from this switch over here. This tells us a lot. This is the main point of all this focus. If I don't get 12 volts over here, let's say I get 0 volts, I take out the connector or I go to the relay and I measure 0 volts. What's my next sequence of events? Should I go over here and measure 12 volts? No, because I'm going to measure 12 volts anyway. Well, it's not going to tell me anything. I'm going to go over here, make sure I get 12 volts over here. Then when I get 12 volts over here, I got 0 over here, 12 over here. That tells me at least, okay, the fuse is good, fine. What about the other side? This needs 0 volts. This needs a ground. I can't give it a ground. You know why? Because the ground is internal in the computer board. I'm stuck. What do I do now? You know what you do? You put a wire inside the terminal, like you see, like I've been doing in all these videos. Please watch my videos, how to test relays in circuit, for fuel pump, for starter motors. You see my technique. You put a coil of wire in there. Don't take out the relays. When you take out relays, it means absolutely nothing. It's useless to me to measure 12 volts here, 12 volts. It's absolutely useless. You want the load connected at the time that you measure it. What can I do? I can't go over here inside and see if this is grounded, but I can give it a ground outside. What do I mean by that? I'll take this point over here. I'll ground it. Doesn't make a difference if I ground or the computer grounds it. As long as it gets a ground, it'll be energized. You understand what I'm saying? Therefore, if I give this a ground, that's all it needs. This will come on, this will come on, and the compressor will come on. That tells me at least, you know what? All of this is working. All of this is working. The problem isn't here. Now, like a viewer said with a comment, oh, you know what I could do? I can jump this. Okay, let's see if you jump it. And which part of the relay do you jump? If you do jump something, I always repeat this in every video because the customers come in with bad computers. Never jump this. If you're going to jump, never jump this. Never jump this. You see this switch? This is just a switch, the contacts. Jump here to here, 87 to 30. Never jump these. Okay? Remember that. You're going to do damage to the computers. Now, keeping that in mind, if you do jump this, and let's say this comes on, the compressor comes on, right? What does that tell me or tell you? That tells you pretty much the clutch is good, the compressor is good because it comes on. But what about, is the relay good? I don't know. Is the computer good? I don't know. You still have too many unsolved questions. By me giving this a ground in one shot, I isolate all this in one shot. It tells me all of this is working, all of this is working, and the compressor is working, and the diode is good also. And it tells me this didn't give me a ground. Why didn't he give me a ground? Then we'll investigate the PCM. But at least I got it down to the PCM. At least I did that much. That's the way I would troubleshoot it. That's the way I recommend it. Please go to the videos how to test a compressor clutch in the circuit with the connector connected to it. Make sure you don't pull it down. If it's 12 volts, make sure it's 12 volts with it connected. That's the most important thing. If you disconnect, it's going to measure 12 volts anyway. What's the difference? But I want to make sure that somehow the resistance did not decrease and is pulling down this voltage. If this voltage is pulled down, he's pulled down. If he's pulled down, he's going to be pulled down. You're going to have problems. That's how I go about it. That's the technique. Please go to those videos on automotive electronic schematics by Joseph. Like I said, I need more views for those. I'll have another video. And thanks for watching.